So today I wanted to have a talk about how I created some of the computer graphics that I've been using in my videos and my plans for future videos, and just have a general chat about computer programming in general and why it makes such a great hobby and how to get started in programming if you haven't done any before. So I'm going to be talking about what's going on here, but I want to start by talking about all this stuff. So what I used for my refactorisation video, how I made all this. And I thought I would also talk about the 3D models I made in FreeCAD for solids of integration in past exam videos. So I'll talk about how this is made as well. So when I was making the refactorisation video, I just wanted like a visual way to represent how numbers can be split up and recombined when you're thinking of products. So I sort of thought of this idea of having like almost like droplets of water that can smush together and pull apart and stuff to demonstrate the way that numbers can be refactorized. So I just modified my normal drawing program that I use. So this is just like my normal thing that I write on. But I've just added a bit that puts these kind of droplets of water. I know droplets of water aren't normally purple, but I sort of felt that they looked cooler when they were purple. Yeah, so all of this is just written in Python, which is a really good language if you're starting out with computer programming. Like, I also really like C, but it's not quite as intuitive. It's very, what's called low level, so it's sort of down at the level of how the computer thinks rather than being at the level of human thinking, kind of. So Python's just a bit easier to understand, and it's pretty simple. Yeah, so it just probably what I should have done is take an object-oriented approach to this. That would have been sensible, but I've never really been able to wrap my head around object-oriented programming. I did take a Java class at university, but all I've done is represent the droplets as an array. It's just an array with the number that's on the droplet and their position, and and then you can just pull them around and they move, and then there's bits in here that sort of detect when one of the droplets gets close to another one. So I think that's that bit. So that's where it sort of recognizes that they're close to each other and starts merging them, basically, like puts it into merge mode. And then this bit here recognizes if you pull them apart too far. So that's like if you're going out to there and that distance between them is getting too big, then it undoes the merge, and this bit will actually combine them into one. So that's when they get really close and they become a new number. So yeah, that's how I did that. Like, I just drew this picture in GIMP, which is like Photoshop. So I use Linux. I think Linux is really good for anyone who wants to do programming because almost everything on Linux is open source. So if there's a program that you're using that you want to know how it works, how they did things, you can usually look up the source code, and you can even download the source code and modify it and recompile it and see how it all works. So an example of that is this window that has my webcam on it. That's a program called GUVCView. And I've modified that quite a lot because I wanted to make it so that it would sort of overlay everything, but it wouldn't be like a big rectangle. It would actually be partially transparent. So this is just a window, and but I've made like bits of it cut out sort of according to the whiteness of my wall behind me. So that's something that like wouldn't have been possible to do if I was working with Windows or Mac, because most programs there are closed source. So you can't read the source code, you can't modify it. So that's one reason that I really love Linux. And Ubuntu is so easy to use these days. Like, you can just download Ubuntu and install it, and you can have it running side by side with whatever operating system you're used to using. So I would actually recommend trying out Linux if you're interested in getting into programming as well. Oh, and a lot of the stuff that I make, I often put it up on GitHub so that other people can use it as well. Like, when I write something like this, I often put it on GitHub. I haven't put this up there yet, though, because like I haven't sort of cleaned up the code and commented everything. It's a bit not user-friendly right now. I sort of slapped it together quite quickly to make that video. So, but if anyone wants to have a copy of that source code, just let me know and I'll upload it. So a little while after I made that refactorization video, I was looking up tetrahedral numbers on Wikipedia, and I saw this little animation that they'd made. I thought, oh, that looks really cool. I wonder how they made that. So it turns out it's made in a program called pov-ray, which actually simulates where the rays of light are going and like how they move through these little glass balls and things. So I thought that was really cool. I actually did my physics honors project on optics, so that's kind of my area. So I was really stoked about that. So I decided to see if I could remake the refactorization thing in pov-ray. So what I decided to do was modify my little program so that it would sort of save the positions of all these droplets or marbles or however you want to think of them. And so it saves like timestamps and like where I've moved these things to. And then, so I take those positions after playing with things in here and put them into pov-ray to create this animation. So I thought that was really cool. Kind of pointless since I've already made the refactorization video. But for, you know, whenever I need something like this in future videos, I'll be able to make it in this nice, pretty pov-ray program. And I think that's important on YouTube. You know, you want to be learning stuff, but you also want something pretty to look at while you're watching a video. Now, one interesting question that came up when I was making this was how to choose the radius of a droplet so that when two droplets combine, the volume of the droplet that results is the sum of the two volumes of the original droplets. So like that droplet has a certain volume, that one has a certain volume. When they merge, the resulting droplet should have a volume that's the sum of the original two. So you might like to think about that and see if you can work out how you would do that, how you would choose the radius so that that works. And another interesting problem was just then how to get the volume to sort of smoothly grow as the two are merging. So like I made it so that, let me just find another bit. So the volume doesn't just spring up when they finally merge, it sort of slowly grows as this one is pushing into that one, as if, you know, the volume of this droplet is increasing because it's getting some of the volume from here, so that it's a nice smooth transition. So those were a couple of interesting maths problems that arose when I was making this. So you might like to think about how you would do that. So when I was making my exam videos about solids of revolution, I wanted to make a 3D model so that you could see what the shape actually looks like that you're trying to work out the volume of. So I decided to use a program called FreeCAD for that, which is like a program for engineers to create little 3D models of whatever they're making. And to my delight, it runs on Python, so that was quite easy for me to get it working and to understand everything. And I think it was just really amazing that there's this free program that does all of this. So yeah, this code that I've written is up on GitHub, so if you're interested in downloading that and playing around with it, feel free to check that out. I'll put a link in the description below. Alright, back to how I picked the radius of these droplets. So what I want when these combine is that, so they're going to make a 65. So I want the volume of a 65 droplet to be the volume of the 5 droplet plus the volume of the 13 droplet. So in general, when you combine two numbers, you want their volumes to add like that. So we've got to think of a function v which gives that sort of behavior. Now, what springs to mind for me is logarithms, because if you go log xy by the log laws, that's log of x plus log of y. So that's exactly the kind of function that we want. So we want the volume to be proportional to the logarithm of the number that's on the droplet. And then the radius is going to be proportional to the cube root of the volume. So to pick the radius, we go cube root of the logarithm, which is what this Python code here is doing. And then it's just got a scaling factor as well. So that's what happens when I combine these. This one is going to grow to be the cube root of the log of 65 times 0.9. And then there was the question of what to do when they're not quite merged yet, when they're just coming together, how to get this to sort of grow smoothly. So, I mean, technically what would be realistic would be to sort of work out the overlap and like add that onto here. I thought that that was kind of too much complication though. So what I did was just do like a linear thing where if they're sort of just starting to touch here, then the volumes should just be their normal volumes. But then as this moves in, the volume of this one just increases linearly until this one hits, you know, right in the middle there. And then they actually merge. So when the distance between them is 0, this one's volume should be like the volume of the you know, the final volume, the volume of the 65. And then the bit of code that does that is just here. It's just like working out how far we are from that final point and adjusting that radius accordingly. So that's how I did that. Alright, so I hope that was interesting for you guys to learn how I made some of this stuff. If you want me to go into more detail about anything, then just let me know in the comments. And yeah, for anyone who wants to start out in programming, Python is really good. I'll see if I can find a good beginner's tutorial for that and put a link in the description. And I would suggest maybe considering installing Linux if you want to get into programming, because I think that that's really, really good, really helpful. And for anyone who likes both mathematics and programming, Project Euler is a really good resource for sort of getting interesting questions that you can work on if you can't think of any programs that you want to make. Yeah, so I'll put a link in the description to that as well.